Good day. My name is Joanna Leone, and I am the Membership Coordinator here at WERC. Thank you for taking the time out of your schedule to join us for today's presentation, How WES is Changing the Status Quo in Distribution. Today's webinar is being recorded and all participants are in listen-only mode. The information discussed in this presentation represents the views of the individuals and does not constitute legal advice or the views of WERC. You should consult with your organization's leadership and legal counsel as needed for your specific situations. At the end of the presentation, if time is allotted, we will have a question and answer period. We will utilize the chat box and question area located at the bottom of your screen or along the right-hand side, depending on your settings. So without further ado, I would like to turn the presentation over to today's facilitator, Dan Gilmore with Softian.
Well, hello, everybody. Thank you, Joanne, for that introduction. Hello to all the audience out there. Thank you for coming for what I hope you will find an entertaining and informative session on warehouse execution systems. WES is changing the status quo in distribution. I was actually scheduled to do an interactive session on this at the WERC conference, and of course, had to be postponed or canceled. So very pleased to have this opportunity over the web. Again, I'm Dan Gilmore. I'm Chief Marketing Officer at Softian. Some of you may know me also as the founder of Supply Chain Digest. Been in this business for a long while, and I've been following the WES thing for a long time. WES has been around for a while, but really it's just risen into prominence over the last few years. We're going to cover all of that. I'm going to cover a lot of ground. We have a fairly hard stop at 1:30, so I'm going to keep it at a brisk pace, if you don't mind. There's a fair amount of detail here. I hope, hopefully that's how you like it. I'm going to cover as much of the insights as I can here in the next 30 minutes or so. So just so you know who the heck Softian is, if you don't, we're a supply chain software provider of a variety of applications, kind of focused around three main areas: warehouse management, which really started the company, and all the things that go with that, yard management, labor resource management, assembly and kitting, those kind of things. More recently, warehouse execution systems really pulled out of the WMS and then expanded and rolled out into its own solution with WMS or by itself, and then what's called distributed order management, or DOM, if you're familiar with that term, which has a lot to do with optimal order sourcing, prominently in the omni-channel world, but well beyond that as well. So that's kind of the suite of products that we have, and you know, it's all a service-based platform. Everything interacts with each other in Lego-type fashion, et cetera, et cetera. So we really have a broad-based suite of solutions, and the usual kind of logos. Like just, you know, the kind of companies we do business with. A lot of very prominent names on there, some more mid-sized companies across a variety of vertical industries. We have a nice customer base. So I just wanted to give you some perspective as to the background of the company presenting this here today for you. So what the heck is a warehouse execution system? That's a good question. Ask 10 people, you're going to probably get 10 different answers. And the reality of it is there is no clear definition. And a lot of people call WES a WES, you know, with very, very different capabilities. Everyone's got a WES, but been around for actually quite a long time, but has gained in prominence very substantially over the last 3-4 years or so, driven in part by e-fulfillment, but not only by e-fulfillment. And it's a really, really interesting story of what's kind of emerging in the warehouse sector right now. So let's kind of go through, you know, a little bit of history here. I hope you'll find this useful. And again, I've been following this for a long, long time. We started out with WMS. I'm not going to go through that. I think we all know what WMS is, but there's also what are called warehouse control systems, or WCS. Okay, and these are the things that this is the software that does the PLC work, that turns the rollers, moves the belts, manages the induction, does the merges, does the diverts, does the sortation, all that. It's the material handling control system at kind of a low level in terms of generally in terms of executing those things. And so I, for a long time, been of the belief that the WCS, warehouse control system, should really just be an executor of what the WMS decides to do, and that all the brains and logic should really go in the WMS. And I'm not the only one that thinks that. Actually, my friend Mark Freilich, who's really one of the pioneers in the WMS industry, a couple years ago wrote that WMS should have all the information it needs to make all the decisions. The WCS should just take that decision about where a cart goes, deliver it, and then tell us that it's there. And that's really the perspective that I've had. And as I'll explain in a second, why if you don't, you can run into some problems. But having said that, that's how I believe it should be, doesn't mean it always is that way. Sometimes, for a variety of factors that I'm going to mention in a second, we wind up, the WCS winds up with some, or even sometimes a lot of intelligence in it. And maybe it's not half and half, but there's only half brain, only brain image I could find. but maybe a third of a brain or something like that is in the WCS and 2/3 in the WMS. Well, how the heck does that happen? Well, it happens for a variety of different reasons. In some cases, the WMS lacks capabilities that are needed to fully support the automation, and the WCS vendor has some ability to add some logic and some smarts into their software, and so the decision is made that that's the way we're going to go, easier than replacing the WMS. In some cases, the material handling vendor, some of these are big giant companies, and sometimes they're kind of in control of the customer, and they want to add as most value as they can, and so they can kind of steer things so that some of the logic and the smarts are in their WCS, and WMS gives up some of that control. And then frankly, oftentimes, after deals are struck, WMS vendors and WCS vendors kind of get together. Sometimes, frankly, this is kind of, outside the view, if you will, of the customer, and they kind of, work out who's going to do what. And sometimes the path of least resistance, even if it's not the right decision, is let the WCS vendor do some of the logic. Why is this a problem? Because when you start to have, maybe you have to do it because the WMS it doesn't have the capabilities, but the other factors, if you wind up needing to make a change, it often means instead of just making it in the WMS and then rippling that decisions down to the WCS for execution, that you have to make changes in both places, and it costs extra money and adds extra complexity and a lot of other factors. So in general, I repeat that I believe that the smart should all be WMS, WCS should just be the execution engine. So along now comes WES, and frankly, WES was, started or initiated a number of years ago by a small number of players. I'm going to come back to that in a second. And the idea kind of is with WES that in terms of picking and order fulfillment and those processes, the brains are really going to be in the WES. The WCS, again, is relegated to sort of just executing the decisions that now the WES, not the WMS, is making. And the WMS in this scenario can sometimes be relegated to sort of managing inbound and reserve inventory and cycle counting and inventory system of record and some of the ERP interfaces, et cetera. Maybe it picks stuff back up for packing and shipping at the end of the process there, but a lot of the intelligence now goes into this new thing called the WES. So how did this kind of happen? Well, WES was invented really by a very small number of companies that sort of had a view that the WMSs primarily were not optimizing the use of materials handling systems, and that in the wave-based kind of processes that picking wave processes that were being used, it often led to big peaks and valleys on the equipment, and that this throttled utilization and throughput and wasn't the optimal sort of way to run a warehouse. And there is certainly some element of truth there. I'd say most WMSs did not well consider, they were concerned about their own efficiencies in terms of picking, et cetera, but weren't necessarily that concerned with the flow of goods onto various automation systems, notably sorters of various kinds there. So, early on, the WES, kind of key capabilities were, improved visibility to, process work, what's happening in different work areas or zones. Some of this you get this last part, the status of the materials handling systems and what's where. Obviously, some of that you can get from WCS, but kind of this granular view. Flowing work more consistently based on capacities and current and projected order volumes. And WES has often been very associated with so-called waveless picking, where instead of using waves to release work to the floor, they're kind of just dynamically released based on a variety of factors, and the goal being to level that activity so we don't have this big peaks and volumes. So that's kind of how we got to where we are today. And again, the WES now has kind of emerged as a much bigger thing in the sense both of capabilities, but also in terms of prominence, driven largely by e-commerce and e-fulfillment, but not completely. And so, when the early days of WES, you'd never see, the analysts at Gartner write anything about it. It wasn't really understood. It was a kind of a materials handling thing or whatever. Last couple of years, 3 years, they've been doing a lot of work on this. This, I think, about 18 months ago from Dwight Klapik and Simon Turnstall of Gartner. They kind of talk about a WCS consistent with what I said. We all know, again, what a WMS is. But on WES, they say it's an emerging, interesting term, hybrid that blends the capabilities both of traditional WMS and a WCS. A WES builds on the WCS's near real-time insight into what's happening in an automated warehouse, but it adds business process logic to this layer. So that's okay. I mean, that's a reasonable place to start, but I would argue one of the issues, and I have great respect for the Gartner analysts, of course, but the key point and one of the key things we want to make today is that WES is now expanded is not just for automated warehouses. It's for manual and more in-between warehouses as well. And that's a key part of the overall value prop. It works great for automation, but other scenarios works very well and additionally works very well. So I'm going to give you a little bit of our definition. It's a bit of a mouthful, but that's just the level of complexity, if you will, of the topic. So the WES to me, provides visibility, control, and optimization of order picking related processes, including but not exclusively optimization of material handling systems work, just in a manner that was far above what's available even in the very advanced warehouse management systems today. So it really is kind of a step change operation there. In our particular case, it works seamlessly with our own WMS, but it can be integrated with third-party or other WMSs. Again, reiterating that key point, which you'll hear yet again, works not only in automated warehouses, but in non-automated, and I'm calling hybrid, mid-level automation. Maybe it's a few levels of pick modules connected via conveyor to a put wall area or something like that, but that's all the automation there is. Works for any and all of those scenarios. It really is, again, kind of this game-changing breakthrough that I think is moving us down the path, as we'll cover, of the autonomous warehouse or the autonomous WMS. That's a term that Gartner's used. It's a term I've been using in terms of a system that is much more automated in terms of the release of work and activity to the floor. Okay. So why do we need such a thing? Why do we need a WES that does those kind of things? Well, there's still a lot of problems out there. There's still a lot of challenges. This is what we hear consistently. First off is a lack of that granular visibility. At an individual node or processing area network, what's going on with throughput and order execution. Second, this is very big right now, labor planning challenges. The right resources just aren't in the right place at the right time. Obviously, even before the virus crisis, we were having trouble with labor issues in terms of people, and now it's going to be nothing but expand. So that's a real challenge for companies. It just takes too long and costs too much money and takes too much time to get the value of adding new technologies, especially picking subsystems, whether that's pick to light, whether that's the put walls that I've mentioned, whether that's mobile robot. Why does it take 4 or 6 months to implement a pick to light system? Could be done faster, drive value more quickly. There's a lot of benefits of WMS, of course, in terms of minimizing travel paths and reduction travel times and reducing picking costs through batching and other kind of technologies. But there's still another layer of optimization, we believe, that can be put on top of that to drive even further efficiencies in the distribution center. This is a big one. I talk to customers all the time in the e-commerce world. Difficulty meeting cutoff times and ensuring service level agreements. When that FedEx truck or that UPS truck is leaving, there's often a certain amount of chaos in terms of getting orders onto that truck and what orders are on, what orders aren't, what are the orders we committed to, and this is it's a handling nightmare really that a lot of companies are really struggling with. We've talked about already that variability in materials handling equipment utilization, and one of the real insights we've come to is that even with an advanced WMS, there's still a lot of reliance on human decision making. And that's a problem in three reasons. One is, the human just can't possibly process all the data that a system can in terms of making that optimal decision making. Second, even if they can, often supervisors and managers just don't have the time to look at all that. And the third, even if they do, it kind of builds in some latency into the process in terms of actually releasing work and other activities, and kind of contributes to less efficiency than if it was all kind of automated and automatic. So that's kind of an initial introduction there, and again, I'm moving along pretty swiftly, I understand. So given that, what is the fundamental value proposition that a WES can bring to the table? It can first off enable companies to meet customer demand and service commitments at least possible cost. You say, Dan, what are you talking about, least possible cost? Well, what I mean is not that you couldn't automate a process and reduce the cost further, or maybe there's even some process reengineering you could do, or any kind of different things. What I'm saying is, for a given scenario today, with these resources, these constraints, this process, how do I consistently make the decisions that are going to meet the demand? That's the first thing, meet the service levels, but then do so in the most effective way possible, okay? And that is the core value that WES is bringing to the table. When you get that, it also, shrinks the gap. I'm calling it between the theoretic, I don't know if that's the right word, potential, but the potential throughput of a DC or a specific area and what's actually being realized, okay? There's a lot of that going on there. I've done a number of calls with companies using put walls over the last couple of months, where they're just not getting the turns in those cubby holes in the wall that they were expecting there, and saying, what can I do about that? What is causing this issue? Because it's key to the productivity of those systems. So there's always going to be a little bit of gap between the theoretic and the actual. How do I shrink that gap to as small as possible? It does provide a single system for management, control, and fulfillment in both automated and non-automated areas across the DCs. The reality it is, a lot of these systems kind of operate in sort of silos and are not fully integrated into the whole, and makes optimization less powerful, if you will, with a silo type approach. WES can provide a unified environment platform to do all of that, and kind of consistent with what I just said there a second ago. WES can significantly reduce the need for human decision making, and moving down that path I've mentioned of the autonomous warehouse or the autonomous WMS. So how on earth does a WES deliver those kind of results? Well, first off, it's kind of the mirror of the challenges. It's by providing real-time visibility to throughput, bottlenecks, conditions, and events that's happening in the warehouse. So, we'll talk a little bit more about that just in a second, but, that visibility is there, and it's not just raw visibility, it's also saying, okay, how is that throughput happening in the case pick area, or the, whatever the area happens to be, how is that against what the expectations are? So if I should be doing 200 an hour and I'm only doing 120, that's a problem. Okay, and so it needs to be highlighted both for the managers to address as appropriate, but also for the system to address. And I'll come back to that in just a second. Direct management and optimization of all those picking systems and other kind of technologies, as I talked about a second ago, so they're not operating in the the robot silo or the pick-to-light silo or whatever it happens to be, but it's all one unified environment that I can move work from one channel to the other channel automatically, and meet needs, or reduce costs, or whatever the opportunity might happen to be. This is really important here, and again, one of the other big changes that's happening is very advanced configurable optimization for things like order batching and release, and the issuance of picking and replenishment tasks, et cetera. We'll show a chart on that in just a second there. That workload balancing to maximize equipment utilization and flow, as I've mentioned a couple of times here already. And then again, back to this notion of automated order release based on a variety of factors that include things like service commitments, shipping schedules, real-time condition monitoring, a bunch of other factors that go in there, so that the system understands what the level of demand and work is versus the resources, and intelligently releases that work to meet those commitments, and does so at least possible costs, as I talked about. And then very interestingly, to address that labor planning challenge I talked about, use of simulation to plan, replan, and to allocate the resources. Okay. So, I can't go through all of those. I would have at the WERC conference here, but just some different examples here. Here's an example of kind of a real-time dashboard showing status across there's dozens of these that you could display or have available to you. A couple key points there. It's just showing different completion of work and whatever. First off, if you click on these, of course, you drill down into the detail. But more importantly, this isn't just for display purposes for supervisors and managers. The WES is also using this information in terms of the capacities and constraints and the actual activity that's happening to make those optimal decisions that we talked about here. So the underlying data not only feeds dashboard type information, but also is inherently used by the WES to improve its own decision making and logic. That's a key point. This is kind of a busy chart, but it's really at the heart of the WES. Okay, and however orders come in, you have an order pool. A WES is going to have a dynamic, engine, if you will, that orchestrates and optimizes orders based on all kinds of factors. The optimization opportunities to begin with, those are often more available at the beginning of the day than at the end of the day, when I'm more concerned about service. What is the order type? What is the SKU type that's on there? What resources do I have available? What is the priority of different orders? How long is it going to take to process different orders? Do they have to go through a value-added service process before they're completed? All these complicated factors are dynamically considered as the orders are available and streamed out based on those to the appropriate channel or picking type, such as you see here in the chart, pallet picking, case picking, each picking of various kinds, pick-to-light areas, all that stuff. And that yellow box, as I've kind of talked about, is so key here, that being aware of conditions and events. So if I've got an auto store, just for example, one we deal with, it's got a capacity, right? And so if that capacity is hit for a given period of time, what do I do with the other orders that you might have otherwise put through there? Well, I can either queue them up and we can understand what's happening in terms of the queue that's developing in the auto store pick route, if you will, or I can, if possible, I can channel those orders to another method, say a pick card, manual pick card, to complete those orders. So factoring in that, am I having bottlenecks, as I talked about in the dashboard area in certain, the value-added service area where I'm not getting the throughput I expected? Do I need to rethink how I release that work or otherwise take corrective action? So, this is a very busy chart here, but really this all happens dynamically and optimally, and it can go across channels. So I have different paths to reach the same result, and balancing that work out across a series of orders and batches. So this gets a little deep here, but just, I talked about the optimization. Here's some examples here where, I'm just describing how a WS can operate there. First off, you're going to this is for a cart type picking. I'm going to do some kind of cartonization, factoring in not only the right carton size and what goes in it and adhering to rules about what can go with what and all that stuff. But when I do all that in the end, then how do I build cartons that have the least travel path associated with them? Then I'm going to also do some form of cluster picking based on proximity of locations to minimize, again, that total travel time. How do I have a set of parameters that's going to factor in things like the number of carts I have? What are their configurations? I've got so many 3x3s. I got so many 4x4s, whatever that mix happens to be. How many carts do I have free right now? Don't have any orders assigned to them, or they're waiting for an operator to come get them. What's the wait time? How long is it going to be before when the carts that are out on the floor are freed up and can be circulated back to begin another round of order picking? What is the resource availability? I may have carts, but I don't have the people. So these are all the kind of things that can be configured about how you want the system to react based on all these different variables. And at the end of the day, you got to strike the right balance between, optimization. You want the most efficient carts that you can, but on the other hand, you have to keep the product moving and meet the priorities and the commitments that you've made. And so sometimes now I may have to, sacrifice a little bit of productivity to make sure the product is still flowing and then meet those commitments. And these things, not only does the WS capable of making those decisions, but you can tune how you want it to operate. Company A may want it to make this trade-off between efficiency and service. Company B may want a different one, and you should be able to go in and tune those expectations. And of course, being able to insert hot orders into the mix. So if I'm in a cart and I've got 12 orders on that cart, if a high priority order comes in, I'm going to remove, oblivious to the operator, if there's a pick ahead of me that has high priority, so I don't have to turn around and go back. I can take an order off that cart, dynamically insert an order into that cart. The picker that's moving that cart has no idea that that switch was made. They're just going to get the instruction about what to do when they get to that location. So here's a second example here, and this is that put wall example. I'm making the assumption everyone knows what the put wall is. If you don't, I don't know what to say. It's a system to efficiently pick kind of typically piece pick type orders there. So if you look at, a cart that can go straight to a packing station, or it can go to that cubbyhole type system that the put wall is, there's a lot of different factors that go into making that decision. Let's say I have a capacity of 10 put wall modules of 40 cubbyholes each. That's 400 capacity. But what if I've got, 800 orders or 600 orders? I have to decide what orders should I send through the wall versus what orders do I send through manual pick carts, okay? And first off, there's some picks that aren't good for the wall. So single line item orders typically are inefficient walls. You're picking them twice, okay? Conversely, let's say that takes 100 out of my 800 out to 700. So now I got 700 orders for 500 put wall capacity. Okay, well, which are the best 500? And it has to do with the density of the picks, the density of the puts. Can I have 6 SKUs that are going to finish 150 of those orders just by themselves, highly efficient? Well, then I definitely want those to go through the wall. And eventually we're going to pick the best 400 or 500, whichever number I gave there, that are going to go through the wall, and the other 300 are going to be handled through manual pick. Okay, so there's just all kinds of different parameters and options that go into making what might seem like a relatively simple decision, but is not. And other advanced features, things like being able to have batch and cluster picking on the same cart, dynamic wall assignments, virtual walls. Do I want to take 4 wall modules and group them as if they're one to get picking efficiencies and reduce the traffic on the conveyor, things like that? Do I have multiple operators operating in a wall module at the same time or not? Do I want wall wave overlap? We were seeing a trend where people wanted to completely get a wave, wall wave, my term, done before releasing the next set of work. Now we're seeing they want to just dynamically interleave. So when a cubbyhole opens up, the next wall wave just automatically is assigned there, and it's dynamically assigning those those locations to gain that significant picking efficiencies, et cetera. So a lot going on just on this kind of simple example. And this is what hopefully you're getting the idea that this is different than we've had with WMS. Some of it might have been available from specialty vendors for walls, whatever, but now it's part of the WES and drives those kind of benefits. So I'm running short on time here. Somebody's like 5 minutes. So just in terms of that resource management, there's some simulation capabilities that are possible. They're basically, you're going to look at the work that's ahead of you, both known and forecast, run a simulation based on the resources that you have, and come back and know what work, where you're well staffed for a given period of time, where you're understaffed, where you are just right, and allow you to dynamically assign and change the assignments of those resources over the course of a period of time. So it can be done based on a recommendation from the WES, or it can automatically assign those people. So a case picker all of a sudden gets done and told you need to move over to piece picking if you're trained in both areas. And this is just a significant advantage in terms of managing resources in the DC. So why do I do all this? Well, this is the kind of benefits that we think the WES can deliver, and we're seeing double-digit improvements in the labor productivity, sometimes more. Significant reduction in supervisory overhead. This is key. This gets into that taking out the human decision-making involved, reduced and just better managed overtime. That improves throughput between the theoretic and the actual of a facility or a given area there. Quickly and easily deploying these new technologies, robots, pick-to-light, et cetera, and doing that and getting time to value in a fraction of the time. Consistently meeting those cutoff times and service commitments and taking away the chaos. The system knows how long it's going to take to get the orders into that truck. It's going to release the orders, therefore, appropriately to make sure that they make it in while maintaining optimization where I can. We talked about the MHE utilization, and frankly, you know, real opportunity. You can do WMS and WES together, or in some cases, you can take WES, put it over top of an existing, maybe dated, aging warehouse management system, and get the benefits of significantly improved performance, and do so without full replacement of the WMS. And again, in an automated, manual, hybrid DCs, works in all three. Some of you may have seen last week of April, UPS did a major press release, picked up very widely in the media, about how they are delivering on what they call the smart warehouse, their smart warehouse initiative. They're doing that in part through a partnership with Softeon for WES. Just search, do a Google search on UPS and WES, or UPS and Smart Warehouse. You'll easily find it. Last week of April talks about a lot of the benefits that UPS has seen in using this kind of technology. So where's all this headed? We really are now in the era of that autonomous warehouse software. It's going to involve automated decision making, taking out a lot of the requirements for humans to try to do that. And then, of course, in this day and age, it's not only going to do that to begin with, but it's going to get better and better through the use of artificial intelligence and machine learning. And we're going to see, you know, just more and more focus. We're seeing this already there on product and process flow, and reducing and eliminating process latency and latency of goods, keeping flowing in the distribution center there. Kind of you might consider the term flow distribution, doing for warehouses in terms of that kind of concept. Similar to what we saw in terms of flow manufacturing 3 or 4 decades ago. So I think I got done just in time, and yeah, I got 2 minutes to spare. Unfortunately, I'm not going to have time for questions here on this session, but if you send me an email, or if you've entered your question in, I will give you a personal response. If you want to send me an email, you see my email address right there, dgilmore@softeon.com. There's a website. There's a very nice brochure on the product that you can find at that link, or just go into the Softeon website, content, et cetera. You'll find it there. And I promise you, if you either send me an email or you put a question in today, I will give you a response. And with that, Joanna, I think I am wrapped up, but I want to thank, I know I covered a lot of ground, but I want to thank everyone for giving me the chance here today. And hopefully I'll see you next year at the WERC conference.
Thank you, Dan. We did have one question that we do want to repeat, and that was someone had asked if there would be a recording of the session. There will be a recording of the session. You will have a link to it as soon as it's available, sent to you via email, along with Dan's contact information for any additional questions. And with that, on behalf of everyone at WERC, we want to thank you for participating in today's webinar. And we would like to thank Dan for being our presenter with us today. We ask you to check WERC's website for future webinars. And on behalf of the presenter and the entire WERC organization, thank you again, and enjoy the rest of your day. Goodbye.
Thank you, Joanna. Thanks, everybody. Still there, Joanna?